Change of order of integration. Changing order of integration means very simply changing limits of integration. How to change the limits of integration means I am discussing the procedure. How to change limits of integration. What I am saying, for example, according to the given limits, you need to do first with respect to x, next with respect to y. This is order of integration. First with respect to x, next with respect to y. Changing order of integration means you need to change. Like first with respect to y, next with respect to x. For that, what you need to do, first identify the region of integration. First identify the region of integration. Very simply what we can say, first identify the region of integration. What it means? Identifying region of integration means identifying the limits of x and y. First write given limits, very simply. What are the limits given in the question? Note down what are x limits and what are the y limits. First note down the limits. That means identifying the region of integration. Next, to change order of integration, if you want to change the order of integration like this, first with respect to y, next with respect to x. What it means? Actually in the given problem, you need to do first with respect to x, next with respect to y. If you want to change like first with respect to y, next with respect to x, you need to draw a strip parallel to y-axis in the region of integration. For that, what you need to do to draw the strip, to draw a line segment, first, next sketch the region of integration. Sketch the region of integration. What it means? For example, x equal to 0 to a. Draw x equal to 0 line, that is y-axis. X equal to a line. On x-axis, draw x equal to a line. If y limits are y equal to 0 to x, y equal to 0 x-axis, y equal to x is the 45 degrees line. So first, identify the region of integration. That means write the limits of integration. Next, according to that limits, draw the region of integration. Draw the geometrical figure for the given region. After drawing the region of integration, sketch means draw the region of integration. After drawing, in the intersecting region, for example, two curves are there, the intersection region is the actual region of integration. In that, to integrate with respect to y first. So actually in given order, x is first. Now to integrate y first, to change the order. To integrate with respect to y, first draw a strip parallel to y-axis. What I am saying, in the intersecting region, for example, if you have a region like this is the intersecting region. Here is one line, x equal to 0 line like that. So if this is intersecting region, in this, to get y limits first in terms of x, draw a strip parallel to y-axis like this. This is x-axis. This strip gives you the limits. How it gives you, we'll discuss in the problem very detailed, in detailed manner. This strip gives, that strip gives the limits. This strip is from x-axis. What is x-axis? Equation of x-axis, y equal to 0. If this line is x plus y equal to 1, if you need y limits, for example, this is 1, then this line is x plus y equal to 1. From this, what is y? 1 minus x. That strip is from y equal to 0 line to y equal to 1 minus x. Then limits will be y equal to 0 to y equal to 1 minus x. Are you getting ma? That strip gives you y limits. In the similar way, to get y limit, x limits, to get x limits, that is to integrate with respect to x first. To integrate with respect to x. This is the procedure to integrate with respect to y first. When you integrate with respect to y first in changing order of integration, in given integration, if you need to integrate with respect to x first, after changing you need to integrate with respect to y. Now what I am saying, in given integration, the first with respect to y you need to do, after changing order of integration, you need to integrate with respect to x first. In this case, R, this is R to get. Draw a strip parallel to x-axis like this. This is strip which gives y limits in terms of x. If you need x limits in terms of x, draw like this. This strip gives you x limits in terms of y. How? This is y-axis. What is the equation of y-axis? X equal to 0. This strip is from this line. What is the name of that line? X equal to 0 to this line name in terms of y. This line name. X equal to 1 minus y. X equal to 0 to x equal to 1 minus y. They are limits of x in terms of y. Then integration will change. First with respect to x, next with respect to y. If you take strip parallel to y-axis, then you will get y limits in terms of x. Then integration will be with respect to y first, next with respect to x. I will tell you in detail while discussing the problem. I will draw the figure. I will take the strip. How that strip gives the limits we will discuss. This is procedure. Now to change the order of integration. Now get the new limits. Get the new limits and evaluate the integral with new order. With new order of integration. Clear, ma? What I am saying, if you want to change the order of integration, first to find out the given limits. Identify region means. First identify the limits. Write the limits, x limits from 2, y limits from 2. Next, draw the suitable diagram for that limits. After drawing the figure, identify the intersecting region like this. In that intersecting region, if given order is first with respect to x, next with respect to y, you need to integrate first with respect to y, next with respect to x after changing. To change the order like that, how? First with respect to y, to integrate with respect to y first, draw a strip parallel to y-axis. Parallel to y-axis, I said how to draw. That strip gives you the limits of y in terms of x. Then order of integration, first with respect to y, next with respect to x. R. The given limit of order of integration is first with respect to y, next with respect to x. Sorry, first with respect to x, next with respect to y. First with respect to x, next with respect to y. After changing, first you need to integrate with respect to x. To integrate first with respect to x, after drawing the figure, in the intersecting region, draw a strip parallel to x-axis. That strip gives you the limits. Clear, ma? After finding new limits, write the new limits. Now evaluate the given integral with new order, changing order. So this helps you to evaluate the integral by changing order of integration. You may have one doubt why we need to change the order of integration. In few problems, we cannot evaluate. It is difficult to evaluate with present order, existing order. Then, if we change the order of integration, the evaluation becomes very easy. In few cases, it is too difficult to evaluate. There is no process to evaluate the given integration as per that order. Then, you have to change the order. I will discuss with one problem where we will get that situation exactly. Okay, I will discuss this complete procedure with your problem. Okay, ma? Now it's done. So now we need to evaluate this integral by changing the order of integration. We need to change the order. What is existing order? So to find existing order, first write given limits so that you can understand. So given limits are very clear. If limits are in terms of x, they are limits of y. This is the technique you need to use to identify. These limits are in terms of x. So these are y limits. That means y equal to x to infinity. And x limits are, if these are y, these are x. X equal to 0 to infinity. Then, whenever y limits are in terms of x, first integrate with respect to y, next integrate with respect to x. I said this one. Variable limits. Which variable has variable limits? With respect to that variable we need to do first. Which variable has constant limits? With respect to that variable we need to do the end. So here y has variable limits. That means y has limits in terms of x. So as per present order, given order of integration is first with respect to x, first with respect to y, next with respect to x. This is order. As per given order, first with respect to y, because y limits are in terms of x, next with respect to x. Now we need to change the order. That means this order will be changed. This one will be 1, this one will be 2. That means first we need to do with respect to x, next with respect to y. For that I said the procedure. First, you need to draw the region of integration. For that, basing on given limits, draw the figure. Here, to draw the figure, definitely you need to draw x and y axis because this is positive region, 0 to infinity. So I am taking this one. X and y axis. Here, y equal to x means a 45 degrees line. This is y equal to x1. Now x equal to 0 means y axis y equal to 0, x equal to infinity line. On x axis at infinite distance you need to draw a line. On y axis at infinite distance you need to draw a line. That means this complete region will be region of integration, but we need to change the order of integration. For that we need to find limits of x in terms of y. To get limits of x in terms of y, you need to draw a strip parallel to x axis in a finite region. So if you take this one as region of integration, you cannot draw a strip in finite region. This is infinite region. That's why I am taking this one as region of integration. This is region of integration. This is region of integration. Okay. Now, in this region of integration, if y limits are in terms of x, first we need to integrate with respect to y. If x limits are in terms of y, then you will integrate first with respect to y. That means we need to get x limits in terms of y. Y limits constant. For that, draw a stripe parallel to x axis. Parallel to x axis, draw a stripe, line segment like this. In anywhere, in the intersecting region. If you draw, this stripe gives you the limits of x in terms of y. Basing on that stripe, the new limits will be x limits. What is the name of this line in terms of x? This is y axis, we know. But what is equation of y axis? Equation of y axis is x equal to 0. So this strip is from this line to this line. What is the name of this line in terms of x? X equal to 0 to x equal to, this is y equal to x. It can be written as x equal to 1. Clear, ma? Now, we need to write y limits. Y is from this line. This region starts from this line. What is the name of this line, ma? X-axis, y equal to 0 line. Y equal to 0 to how much distance this region extended? Up to infinite distance. So y equal to infinity. So these are new limits of integration, which says x limits are in terms of y. If x limits are in terms of y, first integrate with respect to x. Now new order, after changing order of integration otherwise. After changing order of integration, limits are like that. New order is now first, because x limits are in terms of y, you need to integrate with respect to x first, next with respect to y. First with respect to x, next with respect to y. Okay, ma? Now I am going to integrate using these new limits. What is given? Integral 0 to infinity, integral x to infinity, e power minus y by y dy dx. After changing limits of integration, new limits, constant limits, y has constant limits, y equal to 0 to infinity, x equal to 0 to y, e power minus y by y, first with respect to x, right, dx dy. Okay, now while integrating with respect to x, treat y terms as constant. E power y term, 1 by y term. So what you are having? Only 1. Integral 1 dx. Integral 1 dx. X. Limits. X equal to 0 to y. This e power minus y by y is constant. Now write in the place of x, y. E power minus y by y, right in the place of x, y, dy, y get cancelled. Integral e power minus y, minus e power minus y, limits, y equal to 0 to infinity. So you all know that e power minus infinity 0, e power 0 is 1. Using that, keep minus outside, e power minus infinity 0, e power 0, 1. So minus 1, minus into minus plus 1. So see in this problem what happens. If you want to integrate with the existing order, is it possible? Imagine once. If with the existing order, first you need to integrate with respect to y. So here e power minus y by y. How you can integrate? By using uv, too difficult. If you want, you can check. Y power minus 1, e power minus y. You cannot take y power minus 1 as first function. If you take also, what happens? It is too difficult to evaluate. That uv rule will comes continuously without termination. So these type of problems, when with existing order of integration, evaluation of integration is too difficult, then we will change the order of integration so that we can evaluate the given integration very easily. So that is one best advantage in changing order of integration. Very most important, ma. Are you clear? Any doubts you can ask, ma. So now, change order of integration and evaluate. So how I said, to change the order of integration, the same procedure I am going to follow for this problem also. First write limits of integration. I said how to identify limits of integration. If limits in terms of x are limits of y, limits which are in terms of x, they are limits of y. That means limits of y are given limits. Given limits I am writing. Y equal to x squared by 4a to y equal to 2 root ax. Okay. Y equal to x squared by 4a to y equal to 2 root ax. X limits are x equal to 0 to 4a. So this region of integration we need to draw now, because now the present order of integration is y limits are in terms of x. First you need to integrate with respect to y, next with respect to x. For that you need to change the order of integration. That means you need to get x limits in terms of y limits constant. For that you need to draw the region of integration. In that region you need to take a strip parallel to x-axis. For that I am drawing region of integration. So x-axis and y-axis. You know, this is nothing. Y limits again I am writing. Limits of y I am writing again. So this is x square equal to 4ay figure. This is nothing. Squaring on both sides, what you will get? Y square equal to 4ax. So you know very well, if x has even power, that will be on y-axis, symmetric on y-axis, symmetric to y-axis. These two are parabolas. Parabola means you will have like this. So you need to identify these two figures are this one. This is parabola. This is another parabola. You may have one confusion. Which one is y square equal to 4ax? Which one is x square equal to 4ay? For that I am giving one small technique to identify. In which equation you will identify even powers of x square. If you have, that figure will be symmetric on y-axis. That will be on y-axis. That is this one. This is x square equal to 4ay. Which has even powers of y power 2. That figure will be on x-axis. So this is y square equal to 4ax line. So now this will be the region of integration. This is region of integration. That is region of integration. In that region, to change the order of integration, you need to take a strip parallel to x-axis. So like this. This stripe gives you the limits of x in terms of y. Limits of x in terms of y. How it gives? So this strip is from this curve to this curve. So you need to identify the name of this curve in terms of y. Actually this is y square equal to 4ax. What is x? X equal to y square by 4a. Now this one also, this is x square equal to 4ay. What is x? X equal to square root of root 4 is 2. 2 root a1. So now you got x limits in terms of y. X limits are from y square by 4a to y square by 4a to this curve 2 root ay. So new limits of x. So new limits of x is y square by 4a to 2 root a1. Now x limits are in terms of y. Then you have to get y limits as constant. To get y limits constant, you need to solve these two equations now. These two equations can be solved very easily like this. X square equal to 4ay. What is x you are having? 2 root ay. If you write here in the place of x 2 root ay, what you will get? Y square equal to 4a into 2 root ay. Right? 4 2s are 8. If you squaring on both sides, what you will get? Y power 4 equal to, here 8 square, 64. A square you will get a square into a cube 5. Then what is y value you may get? If you take this y to this side, y power 4 by y. What is y power 4 by y? Y cube. Y cube equal to 64 a cube. 64 is 4 cube. 4 cube a cube. That means 4a cube. What is? Then you will get y value 4a. Like that, we can find x and y value by solving these two. So here we need x value now. What is x? 2 root ay. 2 root ay means if you write y value here, you will get x value. So basing on that, one can write y limits like this. This is the region from, clearly here we are having, this is the parabola with the distance up to a, that means here, up to here. Y limits, the intersecting point you need. So the limits are 0 to a, y limits. X limits in terms of y limits in terms of constant limits. Now what is the new order of integration? After changing order, actual order is, given order is y limits are in terms of x limits are in terms of constant. Here the x limits are, sorry, y limits are y equal to 4a. If you substitute in the place of y 4a, you will get x 4a. So y limits are up to 4a. The intersecting point is 4a, 4a. Are you clear, ma? Y cube, 4 cube, a cube. What is y? Y is 4a. If you substitute y 4a, you will get x 4a. So that is intersecting point. Now y is from this line to this line. Y is 0 to 4a. Are you clear how to get y limits, ma? Simply by writing x value here. Squaring on both sides. Clear, ma? Now, as per present limits, the order of integration is, because x limits are in terms of y, first you need to integrate with respect to x. Y limits are constant, next you need to integrate with respect to y. So now we changed the order. How we change it? As per given order 0 to 4a, y, x is from x squared by 4a to 2 root ax dy dx. Now changed like this. How it changed? Y has constant limits. Now in the given region, x has constant limits, x has constant limits, and y has variable limits. Now what happened? Y has constant limits and x has variable limits. Y squared by 4a 2 root ay dy dx dy, because x limits are in terms of y. When x limits are in terms of y, first you have to integrate with respect to x, next with respect to y. But as per given order, y limits are in terms of x. So first with respect to y, next with respect to x. This is given order. What is now new order? Now new order is first with respect to x, next with respect to y. Now we changed the order. By changing order of integration, we need to evaluate. So here we don't have any terms. That's why integral 1 dx. Integral 1 dx is x. Y will be like that. Y equal to 0 to 4a x. Limits from y square by 4a to 2 root ay dy. Now write in the place of x upper limit and lower limit. Y equal to 0 to 4a 2 root a root y minus, if you write lower limit, y square by 4a dy. Now integrate, ma. To integrate this one, actually here you are having root y means y power 1 by 2. Y power 1 by 2. 2 root a is constant. What is integral x power n? X power n plus 1 by n plus 1. What is integral y power 1 by 2? Y power 1 by 2 plus 1 by 1 by 2 plus 1. That means what you will get? 2 root a. Y power 1 by 2 plus 1. 3 by 2 by 3 by 2. Minus 1 by 4a constant. Integral y square, again integral x power n plus 1 by n plus 1. Integral y square, y cube by 3. Limits from y equal to 0 to 4a. Now write in the place of y 4a. Now write in the place of y 4a. If you write in the place of y 4a, This denominator 2 comes to numerator. So 2 2s are 4 by 3 root a. Write in the place of y 4a ma. 4a power 3 by 2 minus 1 by 4a. That means 4 3s are 12. 1 by 12a. 4a whole cube. If you write in the place of y 0, anyway you will get 0. That's why here 4 can be written as 2 square ma. 4 4 can be written as 2 square. If you write 4 as 2 square, what happens? This 2 get cancelled. What is left over turn? If this 2 get cancelled, 2 cube we will have. What is 2 cube? 8. 8 into 4. 8 4s are 32 by 3 root a. Here you will have a also. 2 get cancelled, a cube. So what I did there, I will explain here clearly. You are having 4a whole to the power of 3 by 2. 4 can be written as 2 square whole power 3 by 2. Here a power 3 by 2. This 2 get cancelled. 2 cube 8. A power 3 by 2. Sorry, here you will get a power 3 by 2. Clear ma? Any doubts? So 8 you will get 8 4s are 32 root a into a power 3 by 2. This root a I am writing here as a power 1 by 2. Root a is a power 1 by 2 minus. So cube that one ma, 4 cube 64 a cube by 12a. Now simplify. 32 by 3. A power 3 by 2, a power 1 by 2, a power m into a power n, a power m plus n. If you add the powers, exponents, 1 by 2 plus 3 by 2, 1 plus 3, 4, 4 by 2, 4 by 2, what you will get ma? 2 a square minus. Here cancel the terms ma. If you can cancel with 4, 4 3s are 12 into 4 16s. 16 4s are 1a get cancelled. So what you are having? 16a square by 3. Now if you take 3 as LCM, what happens? If you take 3 as LCM, 32a square minus 16a square. What is 32a square minus 16a square? 16a square by 3 you will get. So like this one can easily evaluate by changing order of integration. What actually changing order of integration? I said changing order of integration means as per given order we will have one order. We need to change that order. As per given problem, the order of integration is first with respect to y we need to do, next with respect to x. How to decide first with respect to y? First with respect to y. If y limits are variable limits means if y limits are in terms of some other variable, y limits are in terms of x, then first integrate with respect to y. Last integrate the variable which has constant limits. So here x has constant limits. So the given order of integration is first with respect to y, next with respect to x. Now we need to change the order of integration. That means we need to change this order. Changing order of integration means simply changing limits. This is the small technique. Changing limits means if you can change the limits of x in terms of y limits as constant like this, then we can integrate first with respect to x, next with respect to y. For that, the procedure what I said, draw the region of integration. To get limits of x in terms of y, take a strip parallel to x-axis. That strip gives you x limits in terms of y limits constant. Then you can change the order of integration. You can evaluate given integral very easily like this. Any doubts you may express ma? Now, by changing order of integration, we need to evaluate this one ma. To change the order of integration, what we need to do? First write the given limits. Given limits These are limits in terms of x, they are limits of y. These are constants, they are limits of x. So y is x square to 2 minus x, and x is from 0 to 1. Now we need to draw the region of integration based on given limits. So I am drawing region of integration mark. So why I draw this one? Because clearly y equal to x square is a parabola. So x power even number that will be on y-axis. X square equal to y. This is y equal to x square figure. So x power even number that will be on y-axis. This is on x-axis. Now y equal to 2 minus x. Y equal to 2 minus x means get x to this side, get y to that side, or get x to this side, x plus y equal to 2. X plus y equal to 2 line, if you write in the place of y0, that cuts x-axis at 2 units, y-axis at 2 units. Because if you write x0, you will get y2. That means that line cuts y-axis at 2 units. If you write in the place of y0, x equal to 2, that means that line cuts x-axis exactly at 2 units. Okay, ma? Now we need to draw x equal to 1 line also. X equal to 1. If you write in the place of x equal to 1 here, y equal to 1. That means the point of intersection of these lines will be this one. If you write x equal to 1 here, x equal to 1 line intersect parabola at 1 unit distance. If you write x equal to 1 here, 2 minus 1, y1. That means this is the common point of intersection for all the curves. So this is x equal to 1 line. This is given y equal to 2 minus x. Okay, y equal to 2 minus x. Now this will be 1 because this is common region. This complete region is common. But this complete region is not formed by two curves. It is formed by 1, 2, 3. This is in this region. If you draw a strip that joins this one and this one, but here this one and this one, it is between 3 different curves, 3 different lines. That's why you need to divide the region into 2 regions. I am dividing like this, using this line. This is not a strip, that is line which divides this common region into 2 parts. This is O point, you know. I am taking this one as A, this one as B, this one as C. Now the 2 regions are there. One region is OACO. Another region is CABC. So in OACO, if you take a stripe parallel to x-axis, this gives the limits of x in terms of y. So this is from y-axis to this line. So y-axis x equal to 0 to this line. What is the name of this line? Y equal to x square, x equal to root y. What about x? Y limits. Y will be from here to here. So this is y equal to 0 line, y equal to 0 to y equal to 1. This is the first region. Coming to the next. In CABC. So limits. To get the limits, draw a strip parallel to x-axis. Then what happens? This strip gives you the limits. This is from this line to this line. What is the name of this line? What is the name of this line? X equal to 0 to x equal to, what is the name of this line in terms of y? X equal to 2 minus y. x equal to 2 minus 1. And y is from here to here. This is 1 to 2. Y is from 1 to 2. Clear ma? This is new limits of integration. Now to evaluate given integral 0 to 1, integral x square to 2 minus x, xy dy dx, you need to evaluate this region. You need to evaluate that one in two regions. One is OACO plus CABC. So in OACO, you know, the limits are x equal to 0 to root y. Y limits, sorry, first constant limits I need to write. Y equal to 0 to y equal to 1. X equal to 0 to root y. Xy dx dy. Plus the second region. First constant limits. Y equal to 1 to 2. X equal to 0 to 2 minus 1. Xy dx dy. First integrate with respect to x now. Y equal to 0 to 1. With respect to x, integral x dx. X square by 2. Limits 0 to root y dy. Plus integral y equal to 1 to 2. So y constant, x square by 2, limits from 0 to 2 minus y dy. Now integral y equal to 0 to 1, right in the place of x root y, I am taking 1 by 2. So right in the place of x root y, what you will get? Y only. Root y whole square y dy. So now this one integral y equal to 1 to 2, right in the place of 1 by 2 I am taking constant 2 minus y whole square into y dy. Okay na? Now 1 by 2 integral y equal to 0 to 1, this is y square dy. 1 by 2 I am taking as constant, this 1 by 2, this 1 by 2 I written here, these two 1 by 2's, plus integral y equal to 1 to 2. This one if you expand you will get this one now. A square, 2 square 4, 2ab, 4y plus y square. You need to multiply this term with y. If you multiply with y, what you will get? 4y minus 4y square plus y cube dy. Now after integrating this, that one, what you will get now? See, if you integrate 1 by 2 constant, integral y square, y cube by 3, limits from 0 to 1. Integral y square. Now that one, 4, integral y square by 2, minus integral y square, y cube by 3, plus integral y cube, y to the power of 4 by 4, limits from y equal to 1 to 2. Okay, now write in the place of y1. If you write in the place of y1, you will get 1 by 3. So here 2 1s, 2 2s. If you write 0, that becomes 0. Write in the place of y2. 2 square 4, 4 2s are 8. Now write in the place of y2. 2 cube 8, 8 4s are 32 by 3. Now write in the place of y2. If you write in the place of y2, 2 power 4, 16. 16 by 4, 4. This is upper limit substitution. Writing in the place of y2. Minus lower limit. Write in the place of y1. If you write in the place of y1, 2. Minus. Write in the place of y1. 1 cube 1. So 4 by 3. Plus 1 by 4. Okay, ma. Now what happens? 1 by 2, 1 by 3 plus 8 plus 4, 12 you will get. 8 plus 4, 12. 12 minus 32 by 3. 3 12s are 12 3s are 36 minus 32. 36 minus 32, 4. Are you clear, ma? 8 plus 4, 12. If you take 3 LCM, 12 3s are 36. 36 minus 32, 4. Now, this one minus. Here, 12 will be LCM. 12 will be LCM. 12 LCM. So, if you take 12 LCM, 12 2s are 24. 24 minus. So, 4 4s are 16. 3 1s are 3. Okay. 16 plus 3. 16 plus 3. 19. Subtract 19 from 24. 24 minus 19. What you will get, ma? 5. 1 by 2 into 1 by 3 plus 12 LCM again. If you take 12 LCM, 3 4s are 12. 3 4s are 12. 4 4s are 16. 16 minus 5. 16 minus 5. What you will get? 11. Again take 12 LCM. Again if you take 12 LCM, 3 4s are 12. 4 plus 11, 15. 4 plus 11, 15. So now cancel with 3. 3 4s are 3 5s are. 3 4s are 12, 3 5s are. So finally you will get 5 by 8. So by changing order of integration, we need to evaluate this one, ma. To change the order of integration, we need to change the limit. For that, first write the given limits. The limits in terms of x are limits of y, and the remaining limits are limits of y. Limits of x. So now, given limits. Here given limits. These limits are in terms of x, they are limits of y. These are limits of x. So x 0 to a, y is from x to a. These are the limits given, ma. Next we need to draw the region of integration to change the order. For that, what we need to draw? Which lines we need to draw here? So x equal to 0 line and y equal to 0 line represents x and y axis. X axis and y axis. Here we need to draw y equal to x line. Y equal to x line means 45 degrees line. This is called y equal to x line. Next, x equal to 0 already drawn, y axis, x equal to a. On x axis, at a units distance, you need to draw a line which is called x equal to a line. Similarly, draw a line on y equal to a. Y equal to x is drawn, y equal to a we need to draw. Y equal to a means on y axis at a units distance you need to draw a line, y equal to a. This is y equal to a line. Now, the intersecting region including this line will be here. This is intersecting region. In that region, to get changing order of integration means we need to change the limits. How we need to change? At present limits are, y limits are in terms of x. Now I need to change, I need to get x limits in terms of y. X limits in terms of y. To get x limits in terms of y, take a strip parallel to x axis. This stripe gives you the limits of x in terms of y. How it gives? See, new limits I am taking after changing order of integration. This stripe is from this line to this line. What is the name of this line? This is y axis. Equation of y axis is x equal to 0. Limits of x I am writing. X equal to 0 to, what is the name of this line? Y equal to x. But we need in terms of x. So x equal to 1. Now coming to y limits. Y limits are constant. we need to write y limits in terms of constant. Then this region starts from here. This line name. What is the name of this line? Y equal to 0. X-axis, equation of x-axis, y equal to 0. To here. What is the name of this line? Y equal to a. So now see the limits. X limits are in terms of y. That means first you need to integrate with respect to x, next with respect to y. But actual order of integration. Y limits are in terms of x. If y limits are in terms of x, first integrate with respect to y. If x limits are in terms of y, first integrate with respect to x. We change the order. Here, first with respect to y we need to do, next with respect to x. But now the order is first with respect to x because x limits are variable, y limits are constant. Now, the region of integration will be like this. Integral 0 to a, integral x to a, x square plus y square dy dx equal to integral. Now change the limits. Y limits are constant. Y equal to 0 to a, new limits. X limits. X equal to 0 to y. This total integration. X square plus y square. First with respect to x because x limits are in terms of y. Dx dy. While integrating with respect to x, integrate x terms only, don't integrate y. That means integral x square. What is integral x square, ma? Integral x square is x cubed by 3, y square constant. So you don't have x here. That means you are having 1. Integral 1 dx. X limits from 0 to y. Now you need to write in the place of xy. Write in the place of xy once. Next, lower limit x0. If you write in the place of xy, what happens? Integral y equal to 0 to a. Write in the place of xy. Y cubed by 3 plus. Write in the place of xy. Y cube dy. Y cubed by 3 plus y cube dy. So if you take 3 LCM, 3y cube plus y cube. How many y cubes, ma? 4y cube. 4y cube by 3 dy. Now write in the place of y 4y cube by 3, right? Total. Now take 4 by 3 constant. Integrate y cube only. Integral y cube. Y power 4 by 4. Y equal to 0 to a. This 4 get cancelled. Write in the place of ya, you will get the answer. A power 4 by 3. Right, ma? Any doubts you may express. So by changing order of integration, evaluate these integral, ma? So here, these limits are in terms of y. If limits are in terms of y, then they are limits of x. So limits, given limits first you need to write. These are limits of x. X equal to 1 to x equal to root 4 minus 1. Similarly, the remaining will be y limits. Y equal to 0 to y equal to 3. Then we need to draw the region of integration now. So now, as per given order, x limits are in terms of y. First we need to integrate with respect to x, next with respect to y. But after changing order of integration, first we need to integrate with respect to y, next with respect to x. For that, draw the region of integration. So if you draw the region of integration, what happens? See, this x equal to root 4 minus y. If you square on both sides, what happens? X square equal to 4 minus y. X square equal to 4 minus y is a figure. Because x has even power, then the figure will be on y-axis. If you have x square, that figure is on x-axis. So this is a parabola that will be on y-axis where it intersects x-axis. If you write in the place of y 0, root 4 plus or minus 2, that means the curve intersect here and here. So like this. Okay, then y value, if you square here, what happens? Get y to this side. Y equal to 4 minus x square, right? Y equal to 4 minus x square means if you write in the place of x0, it intersects y-axis at 4 units distance. So it will intersect at 4 units. So where it intersect at 4 units. How you evaluate it? By writing x0, find out y. That you will get intersecting point. Now, one more line we need to draw. On x-axis we need to draw at 1 unit. This is 1. X equal to 1 line. And y equal to 3 line. If it is 4, approximately 3 will be here. Here you need to draw a line which is y equal to 3 line. Now this is the combined region. So this is the different case where we need y limits in terms of x. If you need y limits in terms of x, take a strip in a combined region, shaded region, take a strip parallel to y-axis. Take a strip parallel to y-axis. That stripe gives you the limits of y in terms of x. This stripe is from x-axis. New limits I am writing. This stripe is from x-axis. X-axis name is y equal to 0, 2. This is y equal to 4 minus x square. This curve in terms of x I need to write. This is actually x equal to root 4 minus y by x equal to root 4 minus y. So if you square you will get x square. Y will be x square 4 minus x square. Here I written 4 minus x square. So y limits in terms of x. Coming to x limits. This is intersecting region, right? From here to here. From 1 to 2. So x limits are very clear in the diagram. Now with the new limits we need to evaluate that integral. So given limits are integral 0 to 3, integral 1 to root 4 minus y, x plus y dx dy equal to new limits. First constant limits, x equal to 1 to 2, y equal to 0 to 4 minus x square, x plus y dy dx. First with respect to y you need to integrate keeping x constant. So x equal to 1 to 2, keeping x constant, integral 1 dy by x y, integral y square by 2, limits from 0 to 4 minus x square dx. Now write in the place of x 4 minus x square. If you write in the place of x 4 minus x square, x into 4 minus x square plus 4 minus x square whole square by 2 dx. Now simplify this one, multiply integral 1 to 2 4x minus x cube plus 1 by 2 into 4 square, a minus b whole square, 4 square 16 minus 8x square x square b square plus x to the power of 4 dx. So now integrate integral x square by 2, integral x cube x power 4 by 4 plus 1 by 2 into integral 1 dx x 16x, integral x square x cube by 3, integral x power 4 x power 5 by 5, limits from 1 to 2. Now simply write in the place of x2 first, write in the place of x2. So if you write here 2 square 4, 4 2s are 8. If you write here 2 power 4, 16 by 4 plus 1 by 2. Write in the place of x2 16 2s are 32. Write in the place of x2 2 cube 8, 64, 8 8 jar plus 2 power 5, 32 by 3. This is upper limit now. After writing x equal to 2. Now write x equal to 1 minus lower limit. If you write in the place of x1 2 minus 1 by 4 plus 1 by 2 into 16 minus 8 by 3 plus 1 by 5. So these can be evaluated lengthy calculation. No need to calculate manually. Use calculator to get the answer. Answer you will get 241 by 60. So use calc here. No need to calculate manually. Just enter like this only, you will get the answer. Okay, ma? Any doubts you may express.